This is The Amazing Beauty of Creation. I'm Bilal Katrada.
And I'm Talha Katrada.
And this is the show that brings you up close with the universe around you. Assalamu alaikum and welcome back to our show. This is episode 2, and today we're going to talk about that giant ball of fire in the sky, the sun. Now Allah Ta'ala says in the Quran, وَالشَّمْسُ تَجْرِي لِمُسْتَقَرٍّ لَهَا. There's a number of meanings to this. One of the meanings is that the sun functions according to very specific calculations that have been laid out for it. ذَلِكَ تَقْدِيرُ الْعَزِيزِ الْعَلِيمِ. These are the calculations of a being who is extremely mighty and powerful and extremely knowledgeable. So what's happening here is Allah Ta'ala is saying that the sun is not just there by chance. It hasn't been just placed there. It just doesn't work coincidentally. These are very, very specific calculations that have been done, very specific measures that have been put into place to ensure that the sun shines in the exact same way daily. So there's consistency, and also there's enough light and heat that will enable life on Earth. Otherwise, if there was too much of heat, then everything on Earth would burn up to a crisp. If the sun was a bit closer to the Earth, then everything would burn up to a crisp. If the sun was further away, then everything would freeze. So everything is very perfectly positioned so that life can be incubated on this planet. Now think about an example of a stove, right? If you turn the stove on too high and the flames are just too high, I'm talking about a gas stove here now. If the flames are too high, then your food will burn, and if your flames are too low, it will take forever to cook. Now in the same way, the sun shines with just a right amount of light and heat to enable life to exist on planet Earth, and it's also at the right distance. Now, how does this all happen? What's actually going on in the sun? Now, Tala is going to advise us on that.
Okay, so first of all, you mentioned that the sun was giant, okay, but just how big is it? Now, the sun has a diameter of 1.3 million kilometers. That means if you were to drill a hole from one side of the sun to the opposite end, that hole would be 1.3 million kilometers long. If you were to compare that to the Earth, so if you were to take the diameter of the Earth is only 12,000 kilometers long. Now the circumference of the Earth, of the sun, if you were to walk around the surface of the sun, okay, you couldn't do that because it's so hot, but if you could, that walk would be 4.3 million kilometers long. Now the circumference of the Earth is only 40,000 kilometers. So there's a very big size difference between the two. Now, just to put that into perspective with the Earth, 1.3 million Earths, 1.3 million planet Earths can fit inside of the sun. But the funny thing is that the sun is not even the biggest star in the galaxy. If you're to take a look at all the stars that have been discovered in the past, the sun is about a medium-sized star. And there have been stars that are discovered that were 100 times bigger than the sun.
So if you had to use an analogy, right? So imagine that there's a man standing and there's a ball, the height of that man. So what's the average height of a man? About 1.7, 1.8 meters, right? So imagine there's a ball, the height of that man. So that ball is the sun. Now by comparison, the size of the Earth would be what? Football? Tennis ball? No, the size of the Earth would be the iris of the man's eye. And I'm not talking about the pupil. I'm not talking about the big, the color part. I'm talking about the dark part inside. So in essence, you can also compare that to a mustard seed. So that man is holding a mustard seed in his hand. That's the size of the Earth compared to the sun. So that mustard seed would be a tiny ball, and the sun would be the ball the size of the man. Now, with these other stars that are much bigger than the sun, think about this. Next to the man, there is a light pole. Can you imagine the difference between the man and the light pole, the height? Now, imagine that light pole was a ball that high. So that would be some of the biggest stars that are found in the galaxy. they, compared to the size of the sun, they are much, much bigger than the sun. All right, so tell us about the fuel. How much of fuel does the sun have, and where does it get its fuel from?
Okay, in terms of fuel consumption, the sun consumes 600 million tons of hydrogen every second. Okay, so that's the equivalent of burning, let's say, 100 million elephants every single second.
Wow, 100 million elephants worth of hydrogen gas every second. So obviously the sun is its fuel source is hydrogen gas, right? And that's a lot of fuel for the sun to be consuming every second. Now, by comparison, the entire Earth electricity consumption over a year. Now listen to this. It's over an entire year. The entire Earth, every single planet, every single country, every single town and city consumes 8.5 billion tons of fuel every year. Now this is including all the types of fuel that we consume: coal, petrol, nuclear power, every type of fuel. 8.5 billion tons a year. The sun consumes that much in 15 seconds. Every 15 seconds, the sun uses as much fuel as the entire Earth in an entire year. So that's amazing. But tell us something, Talan. How does the sun actually burn? Because we know that on Earth we create energy, or rather we generate energy by a process called combustion, right? We burn things in oxygen. Now, on the sun, there is no oxygen, so there's no combustion taking place. There's nothing burning. So obviously there has to be another sort of process that powers up the sun. What's that process?
Okay, so the fuel source of the sun is 90% hydrogen gas, but it doesn't burn the hydrogen in the way that you would burn wood in a fire. You see, the sun burns hydrogen in a reaction called nuclear fusion. Now, nuclear fusion is a process where two atoms, okay, so let's say two hydrogen atoms, are smashed together to form helium. And this reaction releases a lot of energy in the form of light and heat. The sun uses technology that is far beyond us right now. See, that process is pretty much alchemy. You know, the ancient art of alchemy, of taking materials and turning them into new materials. And this is pretty much what the sun is doing in the process called nuclear fusion.
So what you're saying is that with all the technological advancements we've made, the sun is still, technology-wise, still far ahead of us. Is that what you're saying?
Yes, we have not been able to replicate this reaction of nuclear fusion.
Okay, so in theory we understand what's going on, but we can't replicate that on Earth. And on the sun, it's been there for like millions of years. But why nuclear fusion compared to normal combustion? I mean, what's the difference? I would think that perhaps when you talk about combustion has waste products, right? Like now we're facing the problem of global warming, and that's because of carbon emissions. So when you burn a fire, then carbon dioxide is released. The smoke that you're seeing is made up mostly of carbon dioxide. So that's a waste product. And also water is produced if you burn hydrogen, right? So on the sun, I mean, that would have been quite a bit of carbon dioxide. Where would that all go? I mean, that would have been bad for everyone. And I suppose that the combustion process is far less efficient. That means, I mean, you won't get the same amount of energy out of combustion that you would get out of the process that's on the sun right now, which is fusion. Now, to understand fusion, right, how fusion actually works, imagine two water balloons. Now, you take those two water balloons and you smash them together. What happens? You get these two water balloons almost joining up, but there's water released in the middle. Now, this is what's happening. Think of those two water balloons as hydrogen atoms. So on the sun, what's happening is as those two hydrogen atoms are being smashed together, and what's coming out is not water but heat and light, and that's the heat and light from the sun that causes it to glow. That's what reaches us. So this is really amazing. You know, we're looking at just one creation, which is the sun, and we're seeing that as much as we are proud of our technological advancements, the sun has technology that we can't even replicate on Earth. It's way beyond us. I mean, scientists have been trying for decades to create a fusion reactor that generates heat and light, but we haven't been able to do so. So you can see that the sun already has that. And the best part is the sun has just enough hydrogen to burn as brightly and as hot as is needed by the sun, by the earth, by us, the creatures that are living on this planet. So the sun generates just the precise amount. I mean, a few degrees hotter, just a few degrees hotter, and the sun would have burnt up the entire earth. A few thousand kilometers closer and the sun would have burnt up the earth. So you can see that this is not something that happened by chance. This is not something that's just, everything was flung out from a Big Bang explosion and just happened to be there. The sun didn't just ignite on its own. These are very, very specific calculations. These are deliberate. These have been placed specifically so that the earth can survive, and all the creatures, the biggest to smallest creatures on earth, can survive. So that wraps up our program for today, Tao.
Yeah, those are just some of the simpler facts about the sun. We could go on for hours and hours explaining in detail everything that goes on inside the sun.
Yeah, I know you'd love to go along with your sciencey facts, but I think we're going to have to stop there. Okay, so thanks for listening, and shukran. We hope you'll tune in for our next episode, inshallah.
Don't forget to follow us on Instagram and on Twitter at ABofCreation to give us feedback on our podcast and let us know if there's anything specific you'd like us to discuss in a future episode.